Hello my dear friends, I welcome you all in my Dear Mathematics YouTube channel. So today I am going to start a topology series, lecture series. So this topic will help you for GATE exam and CSIR NET exam, and mostly it will be helpful for your interview purpose and also for your semester exams. Okay. So what we have to know this, people used to study metric space before studying the topological space in the most of the college. Okay, but the most important is we have to study both topological space and metric space side by side, because it very necessary. You can see in my lecture video, upcoming lecture video also, why these two things are simultaneously important and why these two things have to study simultaneously. Okay, so firstly I will give about I will say about metric space versus topological. I will give analysis on this. So in real life, okay, in real life we usually give the distance between top two cities, right? Around, we say that around 100 kilometer from my city to my friend city, or distance between two places, we usually speak about that. Okay, or sometimes we speak about that, if you don't know about the distance, we speak that these two state or these two districts present in a state, or these two states present in a country, or these two places present in the district, or these two places present in that country. In two ways only we speak about two cities or two places. Okay, so but there are vast difference between these two statements. In one we are speaking about distance, and in one we are speaking about neighborhoods. Okay, so one is distance between two places, and one is two places in a district. So here we are talking about distance, and we are talking about neighborhoods. So here we have talked about distance, and here we have talked about neighborhoods. So casually speaking, if I write casually definition of metric space and topology, that is loosely, not the exact definition. Okay, if I speak casually, okay, then metric space is nothing but a metric space is, okay, I want to tell you that I will teach you, or I will give the lecture slowly, okay, so that average students and below average students can understand. So if you are getting understand very quickly, so I will suggest you, please increase the speed in the settings section of YouTube to 1.25 or 1.5. okay, so that will reduce your time of watching this video. Okay, so I will give you everything slowly. So a metric space is a set which in which is a set in which there is a notion of distance. While a topological space, I will denote in short TS as topological space, is a set in which there is a notion of neighborhoods. In short, I will write neighborhoods as a NBDS. You know, everyone, you know about this shortcut. Okay, so let me go to the next slide. So what we have studied, a metric space in which there is a notion of distance, and a topological space in which there is a notion of neighborhoods. Now I will give you the conclusion, how we can generally say a metric space is a topological space. Okay, means I want to tell you that, or I want to claim you that every metric space is actually a topological space. Okay, so our target is metric spaces are topological space. Okay, that is, set of all metric space are actually subset of set of all topological space. That is, if any metric space is given, then it is guaranteed that that metric space is actually a topological space. How it is this? So in generally, let me give the literature. So I want to tell you that, or you can see, or you can realize in real life that every distance notion is gives every distance notion gives the notion of neighborhoods. Okay, in short, I am writing neighborhoods as a NBTS. Okay, so how this is this, suppose this is a point. Okay, and suppose you take a distance up to this much from this, and suppose same distance I am taking for, means I am from that point I am taking distance surrounding of the distance. Okay, same distance. Okay, so maybe I draw a suppose I am taking all the point or all the area from this point of same distance. Okay, so now the whole thing, this whole thing, suppose this whole thing is a district and this is a particular place. So I can say that this whole district is a neighborhood of this particular place. Okay, so in mathematics what we can say, if any r, that is distance, is greater than 0, okay, and if we fix a point, that suppose that district, if we fix a point x, okay, then we say all set of points which are at distance less than r units from x, that is, all those points which are less than r unit, that is these points, this point, this point, this point, this point, these points, all the set of all those points which are at distance less than r units from x, that is from x. Okay, are actually form a neighborhoods of x. Have you understood this? Neighborhood of, what is neighborhood of x? Okay, so now, but I want to tell you that other way, means all topological space is not metric space. Okay, in upcoming lecture I will prove this, why all topological space, means there are topological space which are not metric space. That is, in every neighborhood system we can't give the distance notion. Okay, but in every distance notion we can form a neighborhoods, but in every neighborhood system we may not give the distance notion. If you see the example you can understand. So now it is not time to give that example, because there are a lot of things you have to know about distance concept, that is about metric space concept. Okay, so now in the next slide I will give you some notion of use of topology. Okay, not many, just most important use of topology. So in topology we are dealing with notion of distance or you can say nearness notion. Means if you have some points, or if you take any particular element of that set, then from that set you can give the notion of distance or nearness. Okay, means if we now particularly speaking about all those topological space which are metric space. Okay, so now this you can remember that if you have studied real analysis or any analysis topic, that this notion of distance is the most important notion, which helps in two main fundamental topics of, which helps to study two fundamental topics of analysis. That is, one is continuity and other is convergence. Okay, so these two things, you know how much important in your analysis chapter, or if you have studied real analysis. Okay, so now definition of metric space. So you can increase the speed if you are thinking that it is going slow. Okay, it is for every average, lower average, middle average students. Okay, and for you also. Okay, so obviously there is a setting you can increase the speed to hear this lecture. Okay. Definition is, let X be any non-empty set. Okay, because we need points to study the notion of distance. Okay, without any points, how can we say about any distance? Okay, so first of all we have to consider any set which is non-empty. Okay, now define a function. Suppose the function we denote as a d from x cross x to 0 to infinity, or in place of 0 to infinity you can write it as r plus. Okay, you know what is r plus. Okay, because why? Because we will take this x is our set, we will take 2 points and we will see distance between them. That's why that it came as a product, means the every element of this x cross x will be in pair. So obviously if you have only single points, that is a point, you can't give distance of this point from other points, because you don't have other points. So to have other points we need pair of points. Okay, so distance is always gives between 2 points. Okay, and we know that distance is always positive, so the functional value is always positive. It can't be negative, because distance can't be negative in real life. So while real life things bringing in the mathematics, so obviously intuition should be correct. Now this function, this special function d is called as metric. Now there are a lot of function. Okay, so when this function, this d will be called as a metric, means at that time that function will be a special function. Okay, metric on x if for every x comma y comma z, we are taking 3 points, belongs to x, we have followings. That is, distance between 2 points equal to 0, means distance is 0 if and only if x equal to y, and distance between 2 points, if you measure from x to y and someone measure from distance between y to x, okay, will be always similar. Okay, and third point is triangular inequality, property. Okay, that is distance between x z is always less than equal to distance between x comma y plus distance between y comma z. How this came? You know that in triangles in our earlier days we have studied distance between, suppose this is a triangle, okay, distance between, in triangle what we have studied? We have studied sum of any two sides is always greater than equal to sum of, distance between means length of other side. Okay, so suppose this is x, suppose this is z, and suppose this is y. Okay, so now distance between x to z is always less than equal to distance between x to y plus distance between y to z. Okay, it came from directly from triangular concept. Okay, so at the so hence if this function satisfy all these three properties, then d is said to be as a metric. Okay, now if d is a metric on x, then x comma d is called a metric space. Okay, now the most simplest or standard examples are examples of metric spaces. Okay, metric spaces. First one is real number space, that is set of all real numbers, and we are giving distance metric as d as a Euclidean metric. Okay, you have studied Euclidean metric means that is d will take 2 points, I mean the distance between 2 points is given by modulus of x minus y, and we know this, how to calculate this and how to use modulus function. If r taken with this distance matrix, and if you now verify all those properties, definitely it will satisfy. You can check that, it is for you, you can verify this. So r with this metric is a metric space. Okay, and second simplest metric space example is any space, or r with any space you can take here, r with discrete metric. Okay, and that is discrete. How this d is defined, or here I am taking r, but you can take for any set, non-empty set. Okay, this metric space is it is defined by this d discrete is actually defined by distance between x comma x will always be 0. Okay, because any distance between any two similar point is 0, and distance between x comma y is 1 if x not equal to y. If you define in such a way, it will satisfy all metric properties. Hence obviously we can say that d will form a metric, and hence any space or r with d metric will be given as a discrete metric space. Okay, so with this I am concluding. Thank you so much. We will see you in next lecture.